So my name is Jabulani. Some are hearing my voice for the first time. That is why I always introduce myself. Like, who's this now? My name is Jabulani Chitanga. I'm your, they call it facilitator. Is it lecturer? But in this meeting, I'm one of the family members. So it is the difference that I'm a family member who is sitting on the other side. The elders and the families. But we are having these meetings not from the point of knowing, although I am going to teach as well. I think that is okay. So it is these meetings, I decided to host them each and every week because I believe we need to prepare each other towards understanding of, okay, excuse me, what is this? I think you are aware, most of us don't like numbers, don't like statistics at all. Not only you, but if you check even in the whole world, numbers and people, they don't get along. But in the first week, we convinced ourselves that no, we need this because psychology is based on evidence. So most of the evidence is in the form of numeric values. So for us to understand those numeric values, there's measurement of variables, and we have population with a sample. So that procedure of organizing and making an understanding of those numeric values, that is statistics. So we started by introducing ourselves to how do we measure such variables, the levels of measurements. And then we realized that, okay, understanding such is not enough. We need to, okay, if we have data on its own, how does it help us even? So that is when we did the frequency distribution. So with the frequency distribution, we're trying to organize the scores, like the raw scores. Try to organize so that it makes sense, not only to ourselves, but even if we share our data with anyone, they'll be, okay, they'll be able to make a little bit of a sense. So that is why we had that simple frequency distribution and the grouped frequency distribution. There is a reason why we have the simple and the group. The group is used when we have larger numbers or numbers that are far away from each other, so that the summarization makes sense in the organization. And then those frequency distribution, especially the simple one, is used to construct a histogram. So why a histogram mainly? So even the bar graphs and other, they're used to that, but the focus is mainly on the histogram, because the histogram allows us to assess if the data is normally distributed. So if the data is normally distributed, it's based on a theory that the population scores are normally distributed. So when that happens, the researchers are happy because they are able to generalize the findings. We are not there yet in this module, but I think from week number, from week number next week, we start to talk about that. And then having a histogram only also, okay, we get that, but we need a score that is representing all the scores in a sample. For example, if you want to make a decision, so we need to identify a score that is representing all of them. Let's say a sample of 100. We ask them satisfaction or about what is happening in the world now. What is the hot topic now? Okay, I'm forgetting. Mental health awareness month, whatever. Do you know about out of 10? Like some score 8, 7, 6, 5, whatever scores they have. So if we want to report, are people aware of mental health in South Africa? So we need a score that is representing all of them. So that is central tendency. So we have the mean, the mode, and the median, but the mean is the most, is the one that is reported most, because it is based on the central theorem, and then it allows us to assess as well the data point. But we cannot trust that mean much if we do not look at how the other scores are speaking to each other. Like the rest of the scores, how are they far or close from the mean and even from each other? That is why we calculated variability. So that is why we focus on standard deviation, the variance stuff, and the range. But you realize when you read, the standard deviation is the one that is reported most. So it helps us to understand the intention, or what the researchers need is to have a standard deviation that is close to 0 as possible, although it cannot happen, but it is possible. So we need all the scores. If we say 6 out of, if we say mental health awareness is 7, So we expect all the scores and most of them to be close to that 7, maybe 5, 5.5, 6, 7.5, not to have scores of 0, 1, 2, a lot of them in 10s. So it's a problem when it's like that. That is why we calculate the standard deviation. And then, okay, we get that. We moved on to but sometimes researchers want to make a decision to locate, identify, and standardize, especially when different samples have been used in a study. So for comparison purposes, so there's a process that's called Z-scores. So Z-scores are used to standardize so that we can even compare two different samples. Like example that I provided last week, that in a class of statistics and psychopathology, where did you score high? It is used a lot in decision making. So that is what we did until last week. But now, in social sciences, psychology, among others, a lot, researchers always want to predict sometimes what are the chances of something happening. So we don't use the word chance in statistics. So we use the word probability. What is the probability of obtaining whatever score that in a distribution? So you see, if you read the business books and other social science books, they focus on bimodal probabilities, whereby they use the example of, I did that, I think I was in Form 3. What is Form 3? That is grade 10, grade 11. So we had that, like how many dice, how many red dots, how many black dots, something like that. If you read your textbook, you see they mention that. But in this module, we are not focusing on that because we want to have an understanding of the normal distribution. So that is why even in the WhatsApp group, I said, read the first part to get a full understanding, but 6.2, 6.3, 6.5, if I'm mistaken, that is what we are going to be focusing on. So you cannot find or locate that proportional probability without a Z-score. So everything has to be standardized. So standardization helps so that we don't argue like, okay, but you don't compare the probability, your sample is different from ours. So that is why we standardize first. So that standardization allows for the worldwide understanding and decision making of a probability. Like when asked, Jabulani, considering the mean and the standard deviation that is given, what is my likelihood of obtaining a score that is greater than 75%? We are able to calculate that. So that is what we are doing. That is what we are doing this evening. And there's a step ahead of probability where it is used to make a decision to reject or fail to reject the null hypothesis, but that is for next week and other weeks that are coming. So we'll be using the same technique of, I think we are sure that the values are going to be in the tails. So if it doesn't happen, we fail to reject the null hypothesis. But anyway, let's not confuse you. But what I want to achieve in the next maybe 30 minutes, I want to show you how you do the calculations. I'm going to share the slides with you, like what I always do. But I think I've said almost everything. But if I see something as I move the slides, I'm going to mention that. So don't be scared. I just gave you the whole summary of what we did. Don't beat yourself if you're not understanding the statistics. You have to read and practice. And I like the Padlet in that you can see, okay, this is what they did, or even you can do it on your own and compare with our answers. And don't be shy. Hi, Jabulani, I'm getting 2. Why is everyone getting 5? And we are there to help each other. And then if you see every week, I calculate, like I do that like Sunday after church, like I write, I try to not to skip the steps so that everyone can follow. And if you're getting different answers, please don't hesitate to send even a direct message. Hi, Jabulani. But during, with the exception of those outside of the continent, but if you're in this continent, no, man, you also need to rest. So now if I don't reply you, I forget. And then at the end of the term, we are enemies. Jablan was not responding. I think he didn't like me or whatever. It's all about like, I'm here for you to save me. So I think I've said this, the assessment is due unless there are changes because of load shedding. That is what happened last term. Because of load shedding, that week of assessment, we had load shedding, and so they ended up changing due date. The assessment used to be returned at the end of week 6, around the week 5, like June. And unlike you, we used to release the assessment for 1 week and then you download, you write on, but now they're being written online. But anyway, let's not focus on that. So the problem, but I assure you, whatever that you are doing in the exercise and Padlet is what you're going to be asked. If there's something outside of that I see, I'm going to send a WhatsApp to everyone, to the group, to say, make sure you understand this, make sure you understand. But I've covered almost everything. But I don't manage the release of the assessment. So I have access to the due date, and I've seen the questions, but I do not manage the due dates, even for the quiz. Let's not answer this. I wanted to ask you, how are you managing? Are you winning? What do you want to happen? Let's not answer that. So the distribution looks like this. So it's 50% of the proportion on the right, and then 50% on the left. So it's symmetrical. It's a symmetrical shape. Is it correct English? So this line is dividing equally this side. If you add this, it's like 50%, 50%. So the proportion and the probability is actually assessing what is the probability of obtaining. We are going to do that together. Like, how do you know which region to focus on depending on the question? Like that is what they were doing during the COVID-19. They were like, okay, I think the third wave is going to end in October. People will shout, yeah, someone is third hand, they know what they're doing. But anyway, if we're one of those people, like, I'm not being personal with you, but they were trying to also do like this in the probability stuff. But anyway, so we use probability, like what I've said earlier. We can be given this actual scores. For example, the mean, I think you know this is the mean, is it? The mean, and I always say the answers for those who, I think last week the quiz, there was a question that was asking what is the standard deviation of a population? And I think there's a variance, I'm not sure. And the answers were S and something like this, if I remember well. And we covered that. So please, when I say you must try, you must listen. But I think you know this. This is the mean, population mean. Okay, and the sample mean is M. That doesn't make a difference though. So this is the mean, and this is the standard deviation, and then this is the score that is given. But the question is that, what is my likelihood? What is the likelihood, or what is the probability? What is the proportion of someone obtaining a score that is greater than 700? So that is the question. So you cannot identify a proportion. If you open page number 647, I don't know which textbook we have, but it's table B. If you open that table, you don't find the raw scores there, but you see the Z scores and the proportions only. So you should calculate the Z score first every time you are asked to identify a proportion. But if the Z is given, it is easy, is it? But if the Z score is not given, you should calculate that. We did that last week. We're going to do that together. We have 2 exercises and we are going to cover a search. Okay, this is what I said, this table, you need to be at the back of the textbook. And I said this, okay, nice. I know what I wrote. So you cannot calculate like this is what I meant. Like we need to calculate the Z first. But now the problem comes when we don't know, okay, Jabulani, how do I know if I need to make use of the body, the tail, or between? So in the normal, there's no power. Assume this is a normal distribution. Don't laugh at me. So if you're interested in the larger part, that is the body. Let me draw a line here. This is 0. I think you know that by now. This is 1. This is 2. This is 3. And this is minus 1. Remember, I said it's a symmetrical shape. This is minus 2, minus 3. And let's say our Z, this is Z scores. It is 1, like here. And then I'm saying, what are my chances of obtaining a score that is greater than 1? It means this region, is it? Any score that is greater, that is more than 1, is this region. So if you are in comparison to the whole distribution from here to here, if the part that you're interested in is smaller in comparison, you look under the tail. But if I say, okay, Jablan, what are my chances? Some people are negative. Jablan, what are my chances of failing? Let's say, so it means we are interested in this whole region. If you compare the region that we're interested in with the rest, this region is bigger. So when you're interested in such, you check under the body. Someone can say, Jablani, I was forced to study. I just want to pass. But if I get okay, what are my chances of getting between the mean of the pass, let's say 50%, and 60%? Let's say if we calculate 60, it becomes 1. We're going to come back to this. So it means the area that we're interested in, let me select a different color, is this one. So if that happens, it means between the mean and a score. So you look under this column. I'm going to show you these columns as I move down. So I think we understand this. These are the 3 things that we need to understand. I think we can understand as we move forward and ahead as well. Okay, someone sent me these. It means we need to calculate the Z-score before we identify. If you are given an X value, that is what we're going to be doing. This is what I meant. How do you know if you look, and these are the proportions, 0.550, 0.5, 0.5405. These are called proportions. But when they're expressed as a percentage, they are referred to as probability. So it means this is 50%. So if you multiply by 100, you move this decimal 2 places, 50%. It means it's somewhere here. There's a 50% chance of whatever that you're interested in. But let's say it's not at the center like that. Maybe it's 0.30. See, this is a Z-score. So let's say you calculate your Z-score and your Z-score is 0.30. But you are being asked now to, let me just sketch this so that it becomes clear for everyone. Let me use this so that I explain it in a quite, we are using this. Let's say we calculate a Z to standardize, and then our Z score, someone, let's say that's a 60%, I'm just saying. So Jablani, I want to get a 60%, and then we take the standard deviation and the mean, and then when you do the calculation, we get 0.30. That is why last week I gave you an exercise to identify where is 0.30. So this is 0.30. Not perfect though, but if the question is saying, what are my chances of getting greater than 0.30? So it means this area. Where do we check? Do we check under the body, the tail, or the mean? N1, unmute and speak.
The tail.
Thank you so much. Thank you so much. Why?
Because that proportion is smaller than the rest of
but we
the
don't
graph
have the
in totality.
Oh, we don't have the okay, thank you. Okay, I didn't want the word to use the word proportion. I don't know what it means though.
Okay.
Because we do, but I get you what you're saying. I want others to understand. So you mean this area? Can we call it proportion? Yes, I think you're correct.
Yes.
So yeah. So in comparison, this area and this area, this is smaller. What we're interested in is smaller in comparison to this one. That is why you're using the tail. So the proportion is 0.3821. So it's 38% chance of getting 60 and above. Okay. What if? Jabulani, what are my chances of getting less than 60? I don't want to fail. I'm the only person in our family to get less than 60, but what are the chances of that happening so that I prepare my mind? We check under less than 60. I'm saying Z of less than. It's written like this, 0.30. The first one was like this. Am I correct? Yes. Z that is greater than 0.30. And then this is the 0.30 line. That is where 3.0 is lying in a distribution. Remember, this is 0. And this is -1, -2, -3. This is 1, this is 2, whatever, kind of like that. And I'm saying, if I'm saying, what is the proportion of myself failing? Where do we check? Under the body, the tail, or between the mean and Z? I'm not reading the charts if you're typing something. Anyone?
Body.
Why? Why the body?
Okay, this portion now is
greater in comparison.
Yes.
Yeah, that's correct. We are doing this so that everyone understands. If you get that, you'll be fine, even in how we do things. And what I've said also, so this, you can see this, you check under P, because that's the greater part that you're interested in. And then this one, you check under C, when that is smaller, like this. And then that is when you check under C. But when you want to say, okay, I just want to get whatever between the mean score of the class and a 60. So it means the proportion will be like this area. So you check under between the mean and the tail. So the answer is 0.1179. When the question say, what is the proportion? You end there, but when the question say, what is the probability? You write this, but you also express it as a percentage. That is standard. So please, when you answer so you write like 11.79%. Okay. Questions before you start our exercises? And what's the time now? Oh, there's no phone. Okay, got it. Any questions? Hi, Jabulani, please don't stress me. My mind is blowing.
Hey, Jabulani.
Yes, who is speaking?
It's Rahiba.
Yes, yes.
Yes, usually I understand everything, but this time I'm not understanding anything.
Yes, and where I work, I had the researcher. I employed someone, master, that this is the most, but it's doable. It is difficult. I think because of that table at the back of it, but the way that I'm explaining, I think we can. Let us do the exercise and I think it will make sense. But the first thing that you need to know, you can only make use of this table when we have the Z-score. When a Z-score is not given, you need to calculate it first. Okay. So sometimes you're given the raw scores. And then let's say whatever Z-score that we calculate, like now here, we said, okay, we assume that our Z-score is 0.30. Remember last week we calculated the Z-scores. Let's say one of our answers was 0.30, but we are being asked what is the proportion of us getting a score that is greater than this. So we realized that, okay, the greater one is a smaller section like this side. This is greater. of the 0.37. If you compare this and this, what we're interested in is the smaller section. So the smallest is tail, like if we can use a cow as an example. So that's the smaller part is the tail. So now we don't have to look under the body, we get it wrong. So we have to look under the tail because this section is smaller in comparison to this one. So that's the first thing you need to know. This one is red, this one is easy because the question will say, what is the proportion of getting a score of this between the mean? So it's clear and straightforward, but let's do the exercise so that it makes sense to all of us. Okay, anyone with another question? And thank you for being honest, like Jablani, I don't like you anymore. So this another example, just if the Z is 0.25 and if the Z is 0.2, if it is minus 0.25. So for example, if we're saying what is the proportion of getting a score greater than 0.25, it means it's this side. It's bigger, is it? So if you check under the bodies, is 0.59587. But if you're interested in getting less than that, it means the region that you're interested in is smaller in comparison. So we check under the tail. That is the point that I want to send across. Okay, I've said all of this. I want to go to and sometimes in the assessment, this is one of the difficult questions students struggle with. We're going to do that at the end. Remind me. So we are asked to okay, what are the two Z scores separating the middle 60% of the distribution. So if you want to have a proportion of the middle 60%, where should we draw our Z-score lines on both sides? That is what it actually means. So if you're giving a percentage like this, you need to convert into decimal because the proportions in the textbook are written in decimal format. So now you need to go to this decimal or whatever that is close to it and check which Z-score is associated with this. So that is what you do. But anyway, let's leave that for now. Okay, let us start. This first exercise, most of your questions and some of them, they're given like this, but sometimes you are given scores. See this one. Sorry, let me go back again. This is a Z score that is given, but this one is not a Z score. So for this one, we need to calculate the Z first, the Z score, and then do exactly the same, like what we're doing here. So let us start. Who wants to tell us what to do here? Tell me what to do, and then I'll be sketching. So what do you do so that you don't have to, when you submit, you don't have to sketch like this. Let me change the color. We are sketching so that we understand, is it? We don't have to draw everything for ourselves. Our minds have sketches already, but this is okay on your side so that you are able to make a decision in an easier way. So you do like this, and you write a 0 and 1 and 2, 3. I'm waiting for someone to tell me what's the. Okay, anyone? So I'll start with this. What do we do?
So I'll try. Let's see if I get it right. So if I understand the question correctly, it's asking what proportion of the scores are greater than 1.25. So I go onto the table and find 1.25 under A.
Wait, where is it?
In the unit normal table in the back of the text.
Wait, okay, we need to draw a line. Where is 1.25 here?
So it's in the middle between +1 and +2.
Okay, so somewhere here.
Yes.
Okay. So we draw the line first to identify a Z, and then we need to identify which area is greater than that. So,
Yes.
so this line is representing 1.25. That is what we are saying, is it?
So I guess then you would color in the area that you're
Yes.
looking for,
Which
is the tail.
which one is
So
that?
it's
Which
on
area? This one.
The smaller, no, the smaller proportion.
Okay, this one. I was trying my luck. So that's how we learn. I know the answers. We are learning together, isn't it? So if we can see, so we cannot jump to the, I don't know who's, I don't know where the name's coming from. Can you turn off your video, please? And I think someone turned on the video and turn off the mic. Thank you. Except the person is speaking. So why are we saying the tail again?
Because it's asking what z-score is greater than 1.25, which is
Great.
bigger than 1.25, yeah.
Yeah, that greater is the shaded. But why are we saying the tail now? Why are we not saying the body?
Because it's the smaller portion of the distribution.
Okay, thank you so much. That's what I wanted. So we look under the tail. So if you in your textbook, those with the textbook now, open that table, appendix B, B1, you move your eye, I don't know what you used to check, 0.25, next page. Let me actually take a picture for you. I was posted on WhatsApp. Where's 0.25? Where are we get 1.25? Sorry, 1.25 is here. And you see the first column is actually the body. We don't want that, is it? We want the, I can't see, I want to take a picture of you, but I can't, my camera flash is off. I'm in the dark with load shedding. But do you understand? Do you understand? Are you following? So if you check on 1.25, so there's 0.8944, that is the body. But what we're interested in is the tail, that is 0.1056. That is the answer. Is anyone trying? Are you checking where I am checking? You can write point, you can write 0, it's not a problem, but the standard is point only. So 0.105. Is anyone checking? Can you please confirm if I'm correct?
That's correct.
Anyone with a question?
Sorry, so do we have to leave it as 0.1 or do we have to put it in a percentage?
No, if the question, I was about to say that when I was waiting, if the question is saying probability, you write like this one, you're going to write as a percentage. So if the question is saying, so you proceed to write 10.56%.
Thank you.
Thank you. Let's do the other one. Yes, Charlotte.
Hi, sir. I'm going to be honest. I have no idea how we got 0.156.
Do you understand this diagram?
Yes, I understand the diagram.
Okay. So do you have the textbook with you?
No, sir, I don't. Mine's it's a digital textbook.
Yes, if you scroll further down, page number 649, where the appendix B. Did you get there? Tell me when you get there with everyone else.
Yes, sir.
Okay. So if do you see the Z score tables? Do you see the Z values like on the first column, there are Z values like 0 points, or do you see that?
Yes, I see.
You see, and can you, the next page, whatever, we are looking for 1.25. Do you see 1.25?
1.25, 1.25. Yes.
Yeah, so if you check 1.25 under the tail, which value do you see? And do you know why we are saying the tail?
Because it's the smaller portion.
Yes. So which value do you see when you check under 1 point, under the tail.
Tail. Wait, oh, I found it. Okay. Under the tail is 1.25 is 0.4013.
Under the tail, 1.25.
1.25. Apologies, sir. I'm
Okay,
like the wrong answer.
it's fine. It's fine. No problem.
Yes, it's 0.1056. Okay.
Yes, that's how we
Okay.
got that.
Okay. Thank you very much. sir.
While we are there, don't leave the B1. So what are
Yes.
we doing with the B1? So the B is saying Z that is less than. So we are interested in this section.
Yes.
So where do we check now? Under the tail, the body, or the between the mean?
The body.
The body, yes, thank you. What is the value for that?
The value is my textbook. The value is 8944.
444, thank you. That is
Yes.
the answer for that, yes.
Thank you, sir.
Okay, you're welcome. Anyone who is also like, excuse me, what are they doing? Don't they ask? We are part of it. Can you try this one? Anyone who is confused?
Sorry, Jabulani, on the
Yes.
textbook, which page are we looking at?
The one that I have is page 648. If we have a digital one, we are using the
Yes.
table B1.
Digital.
Yes, the first table with appendix B with like those diagrams. You see those normal distribution diagrams, shaded, body, tail, whatever. And now we are locating where the Z score is. And now if we know how to do that, I think everyone is comfortable with that. Now we are like, excuse me, which one do we use now? The body, the tail, or the between the mean? So we have realized that, and we agreed that if the portion is smaller, small in comparison to the other one, we look under the tail. If what we're interested in is bigger, we look under the body. So that is how we got the A, because it's the tail. That's how we got the B1 0.8944, because it is the body that we're interested in. Did you see? Do you get the page?
Yes,
So-
yes, I got it. It's 592, right?
What's that? 5924? Page
the
number.
Yes,
appendix.
Lungisa, my page number is also 592.
Yes, it's right. Yes,
So-
yes, what is important is the table, yes. So I want you to, do you see the Z scores? The first column A. Do you see that?
Yes, correct.
So move your eyes until you reach 1.25. Do you get that?
1.25. Yes, I got it.
And then for A, we agree that it's the tail. We understand that, is it?
Yes, correct.
Yes. So now move your, I don't know what you're using, your finger, whatever, under the tail, where the Z and the tail meet, it's 0.1056. Do you see that?
Correct.
Yes. So that's A. For B now, we are using the body. I think all of us know now why are we using the body. So it's 0.8944. Do you see that? The same 1.25.
Okay.
Do you see 1.25 still? And then
Yes,
under the,
correct.
yes.
Yeah.
While we are there, don't move, don't move. Can you move your eyes to, we are C now. Can you move to 2.18? Can you move again, move until you get to Z of 2.18?
2.18. Let me
Mm.
just scroll down. 2.18. Yes.
Yes, we see it, 2.18. So our
Mhm.
question is saying, what is the proportion of getting a score that is less than? Do you see that? What is the proportion of getting a Z that is less than 2.18? Do you understand that?
Mhm.
So it means this whole section.
Okay.
So where do we check? Under the body or the tail?
The body.
Thank you so much. What is the answer?
0.9854.
Yes, exactly. Yes. That's it.
Okay, now I'm okay. Now I'm getting the
Yes.
idea. Okay, thanks,
Heavy,
Toby.
heavy stuff, you never know about it until we teach you like this. Not only you, I think 99% of people don't know what is this. So if you want to give you problem at home, just open this page. They'll leave you alone. Okay, like I'm busy with school, can't you see? But it's actually the way that we're explaining, I think is, yeah. What if this sign was this side? So it means what is of obtaining a z that is greater. So it means this smaller part. So we're going to look under the tail. Someone wants to try the D one? Someone?
Jabulani, can I go?
Yes, thank you. Who is speaking?
Rahiba.
Yes, yes. What do we do? Tell
Okay,
me.
so we're gonna draw the line between 1 and 2.
Yes, this is the side.
And
Yes,
then we're gonna draw a second line at 0.
at 0, because that is the mean, is it?
Yeah,
So where are we interested in? This side, this area.
it's in the middle.
Okay, so where do we check?
We check under the proportion between mean and z-score.
Which Z score 1.50, is it?
Yes,
What is the answer for that?
it is 0.4332.
Thank you so much. Done. Four, three, three, two, sorry, 3. I sent a video as kind of recording for you, for everyone. I think, I don't know if it's clear. I'm in the dark, we don't have power, but I have a UPS. That is why I'm having a meeting. I didn't want to say to my students, okay, apologize, no meeting. So I decided to buy a small UPS. It works for us. My key. Do you understand? I think
Yes, but the next part is making me anxious now.
yes, I'm anxious too for you. So I'm going to keep, let me just, I like this diagram, it looks nice, but it's not about having a nice diagram. It's about finding the answer, is it? Let me use this color again. Sometimes it's not as easy with a single score. Some people are fancy and funny every time. They want to say, okay, what am I of getting between a B and A? Like, okay, excuse me, why are you doing that now to us? So the first 2 are easy, but the last one is quite difficult. But let's start with let's move fast. I want to get done. I don't want the meeting to be very long. But if you check your Padlet, I have the same question. Sorry, 2. But I think all of us, we know how to identify the line. So what do you need to do here? What is the probability of obtaining a Z that is, what does it mean? A Z that is greater than, is this correct? Let me,
It's less than.
I want to read in English. A Z that is, no, not
Less
less.
than.
No, yes. A Z that is less than. I think I wrote wrong there. Let me see. Let me draw the 0.7 lines here. Let me draw the lines first. 0.7 and 0.70. These are the lines that is where these lines are, is it? But now we want to check what is the Z that is less than and the Z that is, what does it mean also? Less than also.
Yes, I guess that's how they indicate the in-between space.
Oh, okay, thank you. My English is, I don't know. So what you want to do here is you want to check if the Z is between -70 and 0.70. It means, so I draw a line of -70 here and 0.70. So it means we're interested in this part. Am I correct? That's what it means. Okay. So what do we do? What do we get there?
Can I try?
Yes, thank you.
So the first part would be to go back to the table and find 0.7 in your Z scores.
Under what column?
I
The
would
full
assume
column.
Z.
Yes, I mean, Z is 0.70, but we check under
Yes.
body, tail, or between.
We're going to look in column D, the proportion between the mean and the Z in
Why?
that column.
Hmm.
Um,
Okay, what's the answer? I'm with you. I'm not disputing. I just want
Okay.
us to explain. So the answer is 0.25.
580.
Yes.
So if I understand it correctly, because it doesn't, you need to plus those two scores, right?
I'm
You
listening.
need to add them together, I think.
Why? Yes. Why are we adding? You are not
Because-
incorrect. You are correct.
One proportion is to the negative of the mean, and the other
yes.
proportion is to the positive of the mean. So
Yes.
you need to combine that to get the correct
Thank you so
proportion.
much. Thank you so much.
Okay.
So when the proportion, we have a negative value and a positive value like this, it means you are adding the between of the mean for this side and the between of the mean for this side, of which the negative doesn't matter. It's just showing that the score is below the mean. So it means you are multiplying by 2. So it's 0.2580 plus 0.2580. Is the same because they're both at 0.70 as a Z score. So this is a Z of minus 0.70, and this is a Z of 0.70. The negative or the positive is not important. What is important is what is the proportion of such. But why are we using between the mean? It is because these two values are actually the mean, 0. The other one is this side of the mean. The other one is this side of the mean. So this, I'm coming to you, Wolfgang. And then we are adding this between the mean, and we are adding this between the mean. Yes, Wolfgang?
I did it a different way, but I think I came to the same
Yes,
answer.
yes. What's that? Tell me. I was going to go there.
So firstly, I went to 0.7 on the table. And at first I looked at the body column
Why the body?
because the proportion in the body, like I went from negative 0.7 to towards the right of the normal distribution. And then I subtracted the tail column of 0.7 and I got to the same answer.
Okay. So what you can do, you can say 1. So the total proportion is 1.000. So it's either you can identify the tail of 0.70 and the tail of this side of 0.7000, and then subtract from 1. You get the same answer. Because we are eliminating this side, and then we subtract from 1. That is how we can get this proportion as well. But what the first speaker said is the easiest. What you are saying, Buhle, is what we do here sometimes, and what I'm saying is what we do here as well. Because both proportions are in the negative, we cannot always do the between the mean if both lines are in the negative, or if both lines are in the positive. Yes, Raiba?
Okay, so Jabulani, the 0.2580. Are we supposed to add these both numbers, or does the number stay
No, we are adding them, sorry.
Oh, okay.
Okay, we are adding them. Because the first 2.50 is the proportion of this side, and the other one is for this side. So that is why we are adding them. So it's 0, 6, 0, 5 point. And what I'm saying is that you
Isn't it 5160?
What is the answer?
5160.
5 point, where is 6? I added this and 6 and 5 plus 5, what is it?
But aren't you going to carry the 1?
Oh, sorry. Excuse I do apologize.
No problem.
Yeah. But you are not, if we continue practice, you will get it. What we mean. And this meeting is being recorded, so you can go and check. Otherwise, we'll finish at 8. So you do that when you have a negative and a positive. This is a positive. They don't write the positive value. It means it's a positive. You do the same for this one. But the difference that now we are not adding the equal values. We are adding 0.2580. And we check what is Z of 1.00 and we add the 2. Okay. What is the answer for that? Can someone check what is Z of 1.00? Let me write 0 here. People are getting confused. It's 0 point. Can someone check what is the proportion of 1?
It's 0.3413.
0.34.
13.
So we add that. I think proportion is bringing 15 marks on your assessment, if I'm mistaken. 3, 9, 9, 5 point. So that is the answer. Or you can do the same. You check the tail, and subtract from 1. So you add first the 2 tails, and the answer is subtract from 1. So the tail plus the tail, and then you subtract from the whole proportion. So you get the same answer. What Bushle did, you can make a mistake, although you can get the same answer, but it's risky. I'm even scared to kind of think about it. But if it works for you, it's like that. Also, before you write the answer down, just think for yourself, like, if we can consider the shaded area, is it more than 50%? Is it less than? If you can check, if you doubt your answer, let's say, for example, the shaded area is this. It will never be more than 50.550. Do you understand what I'm talking about? So it means it should be less than that, like 0.3 something, 0.4, whatever. So that is one of the skills that you can use to check if your answer is correct as well. But now we have what is the proportion of getting what is the proportion of getting a score between -1, -2, -3. So it's -0.50 here and here. So it means we are interested in this section. And this is -0.50. What do we do? Someone different?
Can I try?
Yes, who is speaking?
Bushe.
Okay, yes.
I first looked for 0.5 on the table and I went to the proportion in tail.
Why tail?
I can't really explain, but I understand.
Because if you look the tail, we are actually getting into this area.
Yeah.
So, okay, under the tail, what is the answer?
It's 0.3085.
3085.
Yes.
And then?
And then I looked for 2 on the table. And I looked for the proportion in tail again.
Okay. What is the answer?
Sorry.
What is the answer?
It's 0.0228. 0.228. And then? I subtracted the 0.228 from the 0.3085, and I got 0.2857.
0.28.
57.
Okay. Let me try. Someone else? What do you think? We have this answer from Bush.
I got a different answer.
Yes. What did you do?
So I went down to find the score next to 0.50, and I looked between the mean and the Z.
Why mean?
And I,
The mean is here. The mean
okay,
is not. The mean is not involved.
okay,
Yes. That if you do that, we're including a proportion. This one is not part of it.
okay.
Mm.
Would you subtract that then in some way?
Like from what? From
I don't know.
Yes.
Okay, I don't know.
Okay. So what I would suggest you to do. Remember, I said this whole
Can I
proportion-
try?
Yes. Thank you. Thank you.
Okay, so what I did first was I got the body for 0.50,
Thank you. I will do that.
and that's 0.6915.
0.6195. Who is speaking?
Shazia,
Okay. Yes. Thank you.
6915.
Yes. So we are eliminating this part from the rest
the-
of yes. And then the next part, what did you do?
I got the body for the 2,
Why the body?
because if you take this body, the body for 2 and the body for 0.5, and you minus it, you get the piece that's left over. I got the exact same answer as 0.2854.
Okay, let me try what I want to do. I'll check the tail for minus for 2. What is the answer? Can someone check the tail? I want to eliminate this. So what I want to do, I have the whole section, but I want to eliminate this and this and be left with this, what we're interested in. Can someone check what is the proportion under 2?
It's 0.0228.
0.228. And then I add the 2. I'm going to subtract from 1, the total for this. That is the easiest in the way that I understand it. I don't know if you're going to get the same answer. I don't know if the answer. What is the answer here? That is 3. That is 2. Is it 2? Is it 2? Yes, am I correct? And then 1 plus, that's 3, that's 4. Is it? Am I correct? And then this is 6 points. And my answers and yours are different. And I say 1. Why am I saying 1 minus? Because this whole proportion is the whole. So it's 1. All this point are decimals. So we are not interested in this area. So this is this. We are not interested in this area. So this is this. And I'm adding what I'm not interested in, and I got this from the total. So that is the answer. What is the answer for if you say 1 minus 0.6423? Can someone do that with the calculator?
The first, it's not 0.6195, it's 0.6915.
Which one? I was asking, which one is incorrect?
The top one, 0.6195.
Yes. I
It's
wrote like this.
0.915.
Okay. Okay, thank you. Thank you for checking.
And
I'm
that
not checking
gives
anyway.
you 0.6687.
0.66 8, 7. If
And
I'm
you
not check-
subtract 9
yes,
from the and 1 from the, it's 0.3313.
yes, 3, 3, 1. This is, I believe this is the correct answer. I don't know if the answer though. I don't think this one. Why am I not thinking this one? Because you used the tail and you included the shaded region as you did that. I don't know if someone is understanding what I'm saying.
Now I'm confused, Jabulani.
Where are you confused?
Which one is the correct answer? Is it the 0.3?
This one.
Why is that one incorrect? Is it because they Buhle included the shaded
Yes.
part?
Bushle, the first, what did you say? How did you get this one, Bushle?
I first used 0.5
Yes.
and I used the tail portion of it.
Yes, of which if
And
you
then-
use the tail, you are including this part.
Yes, I included that
Okay.
entire, and then I
Yes.
subtracted the tail from the -2. Or from the Z table, it's just written as 2. So I got the tail portion of 2 and I subtracted that from the tail portion of the 0.5.
So the first part of your proportion included everything
Yes.
from this is the mean.
No, it included everything from the 0.5.
Yes, I know. Yes.
Oh,
yes,
yeah.
I mean, this is the mean. And then the second part of a proportion, of which is -2 is here. It is here.
Yes.
And you checked
It
under what?
included everything on the tail part of the 2, the 0.0228. And then I
Which-
subtracted that
Which
from,
which is this?
yes,
And then
I subtracted the tail part of the 0.5 from the tail part of the 0.2.
no.
Mm.
No, you are including, there's something that is missing because you are using both sides of the tail, of which you are supposed to eliminate from the whole. So this is what you do. I was trying to check if you get the same answer. I don't think so. Even if that, but I don't know how you got the same answer here though. Where is it? Somewhere. No, this one was a little bit different. But this one it is because both scores are on the negative side. So this is the answer here.
Sorry, so but when I did it the other way, where I took the two bodies and minus it from each other, I got the same answer as Bushle.
Why is the other one is not a body? Why is it a body? It's a tail.
No, I did it the other way. So I
Okay.
took the body of the other side
Okay.
because it's not,
So this is 0.
Yeah.
And what did you do?
so I took the bigger portion of the 0.5.
This side.
Yes, that portion.
We are not interested in that at all. Yes.
Oh, okay. And then I took the,
It is not part of what we're interested in. What we're interested in is this. Okay, can you proceed?
and then I took the body of the 2.
Where's the body of the 2?
It's this whole big part, including the part we're looking for.
Yes.
And I subtracted the 2 and I got 0.2857.
What about this part then?
But we're not looking for that part.
But we
We're
are not
looking
also,
for in between.
but we're also not looking for this. It's not in between because this is the mean. You understand what I'm talking about? So there's a section that we are missing in your proportion, meaning this answer is lacking the involvement of the other section from the total of the distribution. That is
So
what
when
is
we have
happening.
questions like this, we have to take the whole thing
Ye-
into
Into
proportion.
consideration, exactly. Do that.
Okay.
So we're even listening. So everyone who is listening and watching, do that. So let me just clear everything. Let me clear the other section so that we don't finish the meeting confused. I don't want anyone to lose. I don't know the question. I don't think there's a question like this though. But anyway, I'll check. What I'm saying is this. Okay. We have, yes.
Sorry to interrupt here, but I also did it a different way, and I'll send what I did on WhatsApp, and I also got the same answer as Bushi. But I used the area between the mean and the Z.
But we don't have that. That is incorrect.
But if you subtract it, like I'll show you my reasoning, it should give you that area that we're looking.
Okay, this is the area that we're interested in. We all agree. And what did you do? Can you proceed?
So what I did was I found that that area on the table between the mean and Z for -2 or for 2, which is 0.4772, and then I look for the area between -0.50 and the mean, and then I subtracted that from the first reading I took off the table, and that should give you that. If I understand it correctly.
The first one you said between the mean and -0.50. That's what you're saying, is it?
No, the first one you need to look up is the between the mean and 2.
And 2, this area.
Yes, that whole area, yes.
Yes.
And then the second one is between the mean and 0.05. So
which is this area?
Yes. So in my opinion, if you subtract the smaller area from the bigger area, you should get the area that you're looking for.
But why are we including the mean if this area is not involved?
But if we subtract that from there, we are getting the area we're looking for, isn't it?
No, I don't think so. Anyone else?
Well, if you took if you take that area off there, you are left with only that area that we're looking for.
So for example, let me just try to explain. If our question, let us ignore this. If our question was, what is the proportion of obtaining a score between -2 and the mean? Let's start from there. That's what you're saying, is it? So we're going to look, so it means this whole area, like from here to here. That's what we mean, is it? So if the question was this only. So that is what we did.
That's not what I mean, because I'm taking the other area off it to get to that area that we're looking for.
No, we want to start, what I'm saying is that, so let's say if the question was, what is the area between the mean and minus, that is what you said, because I started from here and to the mean. Let's start with the other way around. Okay, tell me, I want to draw that for you. If we were interested in only the first one, what did you do again?
So I took the area between the Z score and the mean.
Which Z?
2.
Okay, so this is where 2 is.
Yes.
This is where the mean is. Yeah. So this area, yes.
Yes.
What is the proportion for that?
That is 0.4772.
4.772, yes.
And then I took the area between the the z-score of minus 0.50
That is here.
and the mean.
Yes, this area.
Yes,
This area. This tiny area here.
yes.
Yes.
So technically, if I,
What is the answer? Give me the proportion for that.
so that one is 0.1915.
1,
9,
9. Oh, sorry,
One.
let me. One.
9, 1,
Yes.
5.
Yes.
And that comes to the same answer as Boosley calculated.
So what did you subtract? What did you do?
I subtracted that because we are looking for the area excluding the small area.
Okay. Bushle, I see your hand is up.
Hi, sir. Your method is correct too. It's just the addition that isn't. I think we should all get to the same answer.
Okay, wait, what is incorrect?
6.6915 plus 0.0228 should give you
Yes.
0.7143. And if you subtract that from 1, you should get 0.2857.
Okay,
Like
let
the
us
rest
let us add together again. I was expecting you to give me answer. Can we add again together?
Okay.
Because I know my answer is correct. I want to argue with your complex formula.
Sorry, quick one, Jabulani. Are we
Yes.
adding or are we subtracting there?
I am adding. Let us ignore Bushle and do we speaking again? We're not ignoring them, but let us start with ours. Let us add together. What is the answer again? Can you give me the answer here, Bushle? That is 3.
It should be 0.7143.
Okay, 0,
7143.
7. Sorry, my network. 7, 1. You see, people are not helping me to do the additions. And then if we subtract this from 1 now, what is the answer, Bushle?
It's 0.2857.
Oh, so we have the same answer.
We all have the same answer.
So I was right in arguing with you. I was like doubting, no, my answer cannot be wrong. But what you are doing is hectic. You guys will die. Don't do that.
Sorry, can I just ask why after 0.714 do you subtract
Because you are considering the whole distribution. The whole distribution is 100%. See this line that I drew here. The whole distribution is 100%, but you are using decimals. So it's 1.00. That's the total, is it? All these are smaller numbers in a distribution. So I eliminated this and I eliminated this to be left with this.
Okay.
That is what I'm doing. It's quite easy. What you're doing, I don't even understand it. Mostly, I don't know where you come from and your friend. I'm joking. But if it works for you, do it. But I'm scared to tell the rest to do that. I don't even remember why and why. But okay. But if it works for you, or if it's fine with you, it's not a problem. But what I'm saying is that for us to move away with, we are eliminating the proportion that we're not interested in, of which is this from here up to here. So we check under the body of 0.025. We got this. And we want to eliminate this because the smaller in comparison to everything. So we check under the tail of 2 and we got this. Do you understand, is it? And then we added this, and you guys let me down. I was adding and my addition was incorrect. Thank you, Bushle, for checking. And we added this and then subtract from 1. We got the same answer with the other 2 members of us. So I think this is easier. But if the Bushles and the exam works for you, but I'm not even understanding it. So I eliminated this to be left with the area that I'm interested in. That is why I'm subtracting from 1.
And do you get one on the unit table?
No, we don't have one. It's a raw number. We are subtracting.
Okay.
Okay, so this one is from here to here to make it 100%. So the unit table at the back, those 0.997 point, it means if we add the body and the tail on any Z score, it will give you 1. If you add column B and column C, it will give you a total of 1. That is why I'm subtracting from side. Let's do the last one and then we call it, guys, this meeting is